In exercise 8C, we were introduced to the concepts of simple interest, flat rate depreciation, and unit cost depreciation, all of which required us to have a starting point and a rule to determine the next term in our sequence. As part of exercise 8D, we start to look at how do we generate a rule for the nth term. When we generate many terms, if we need the term prior to that, that can become quite tedious if we are looking for term 20 or term 30 in our sequence. So it is important to generate a rule for the nth term. And this is seen specifically when we work through an example. For instance, if you have $2,000 to invest in a simple interest investment, so it's an investment, therefore we are giving that to the bank, and it pays for us 5% interest per annum. Your investment that way will increase by that same amount, that 5%, and when you work that out, 5% of $2,000 is $100, so each year it will give us $100. So if we write that as a recurrence relation, we started with our starting point, V0, was 2,000, and then we said for each additional term we were going to add $100. So if we are at Vn, our next term is Vn plus 1, so we would need to add 100 to that. And yes, we could be generating each of the subsequent terms by just putting that into our calculator, starting with 2,000, pressing enter, adding 100, and then just pressing enter each time. But you wouldn't want to be doing that continuously for 30 iterations or for 50 iterations. So therefore, because we know each time we are simply adding 100, we have to see, well, how many lots of that 100 do we need? And then we can add that to our initial investment of $2,000. So that's where N comes into it. For example, in this particular situation, if we want to find out what's our investment worth after 20 years, we would be using the rule V20 because we want position 20. We want to know how much is in there after 20 years. We started with 2,000. We're going to add to that 20 groups of 100 because each year it's going up by 100 in those 20 years. So at the end, we have an investment amount of $4,000. So that rule can be generalised for any linear growth or decay situation. So, just recapping that, we have a recurrence rule in the form V0 equals our initial value, our starting point. Vn plus 1 is the term that we wish to generate from the previous term, which was Vn, plus D, where D in this case is our constant. For linear growth, we are going to be adding D each time. For linear decay, we are going to be taking away D each time for however many number of terms we need. So those general rules, those two general rules there for linear growth and decay, satisfy our requirements for simple interest investments and loans, for flat rate depreciation and unit cost depreciation. Remembering that depreciation refers to decay because it's reducing and we're using minus there, whereas an investment that is growing, we're using in this particular case addition or linear growth.
So really it's just exactly what we were doing yesterday, except the major difference is now this little M part, isn't it, Miss?
It is.
That's
because
all it
that
is.
tells us how many terms we require without actually having to work out every individual term.
Yeah.
So the simple interest loan is simply the same rule that you're familiar with. The only difference is the inclusion of N. So you can see those listed below. So Vn is equal to V0 plus N times D, where D we know comes from the rate, the percentage, times the original value. that was our principal or our initial amount invested, or you can write that out with the expanded form of R. But those two rules there are the same. They are identical. Flat rate, same rule as you've previously seen. The only difference is we have N included. So Vn is equal to V0 minus N times D. And you can see that N represents the number of years that you're referring to or terms that you require. Unit cost depreciation, again, very similar to the previously used rule. Vn here is equal to V0 minus, because it's depreciation, N, the number of units in this case, times D, which is the cost per unit of use. So we have a look at a couple of examples here. The first one, we've been given that recurrence relation below, and it models a simple interest investment. So money's going into the bank, and we can see that it's $3,000 that's going in because that's our initial starting point, and we refer to that as the principal. So what is the principal of the investment? In this case, it's $3,000.
And then it looks like it's increasing by 260 because of this right there, plus 260, so it's increasing, and we said it was an investment, so that's what it is. So first question, what is the principal of the investment, which was 3,000, and how much interest is added to this investment each year? And it's just 260, because we can actually answer that from there. Now the next one says write down the rule for the value of the investment after n years. So
we would do that so that we wouldn't have to do all of the individual iterations, because if you see in the next question, it's asking us to find out after 15 years. Now, so that we don't have to do that, we have to establish our rule in part B. And effectively what we're doing there is saying Vn is equal to VO, which in this case is 3,000 for us, plus N times 260, because we're going to be paying 260 each time, or that's the interest, that's been earned each time. So our rule there is Vn is equal to 3,000 plus 260n, because we normally put the number in front of the variable.
Right, so for 15 years, which the question was asking us for, miss, so we just put in V of 15 equals, and we write out 3,000 plus 260 times 15, and that will give us 4,200.
If you want to include brackets there around 260 times 15, you can do that as well.
Okay, and then the next question was, use the rule to find when the value of the investment first exceeds 10,000.
So the value is, in this case, that's our subject. We no longer want V0 equals, we want Vn. But Vn, in this case, is an amount. We want to work out how long will it take before our investment is actually worth $10,000 or more. So we're saying $10,000 is equal to, and then we've got our rule, and effectively what we're doing is trying to find out what's n worth. So you could use your solve function on your calculator there and simply put in 10,000 equals 3,000 plus 260 times n, comma, n, to find and get your calculator to solve that. And if you work through that, you'll see it's 26.92 years. So it will take a minimum of 27 years, if we round that up to the next whole number, for the investment to exceed or go over $10,000.
So guys, don't forget, they said use a rule to find the value of the investment when it first exceeds 10,000. They've asked you in a sentence, what do you have to do? Reply with a full sentence like that. So the value of the investment will first exceed 10,000 after 27 years. If you don't write that out in your SAC especially, you will lose marks. You have to answer with that.
Next example, very similar in nature, simple interest investment of $4,000. The rate there is 6.5% per year, and we're asked to write a rule to find the value of the investment after 10 years.
So they just want the rule, don't they?
They just want the rule. That's in this case.
Easy.
So in this case, we just want V10, because that's what we're looking for, is equal to, now that should say...
See, but Miss, wouldn't I write out the full formula first?
You write out the full formula, but there's an error in the question. That should actually say, rather than 4,000, it should say 3,000.
Yeah, there's heaps of errors in this. So that's 4,000 here. 4. Okay.
No, I would change the other one to 3,000.
Or change the other one to 3,000, whatever. It's up to you guys, but you know that, there's always errors in this textbook.
Okay. The next example follows flat rate depreciation. Very, very similar. The only difference here, because it's depreciation, it means it's going to be decay. So it's reducing. So that's why we've got our negative there. You've been given the recurrence relation. What's the initial value of the furniture? You can work that out straight away. It's 12,000.
There it is.
By how much does it decrease by each year? Very clearly, it is $1,200 there. That's how much it's going down by. You're asked to then write down your rule in part B, which you're able to do now. Part C then says use that rule, work it out for 6 years.
Times 6, straightforward, isn't it?
Very straightforward.
Very easy. And then the last one is actually doing the whole thing, and there it is there for 4 years. V4, substituting, guys, and it's done. Very easy. Next one.
Okay, this one here is a little bit different because it's unit cost depreciation. So if a hairdryer in salon, a hairdryer was purchased for $850.
Expensive hairdryer.
The value depreciates by 25 cents every hour it's used. So we need to look at writing a rule that makes this work. So we've started with a cost or a value, an initial value of 850, so that would be our VO, and it depreciates by 25%, so we would change that to 0.25, and we're saying that that's for every hour. So if you have a look in the solution there, the rule would be VN is equal to 850 minus 0.25 times the number of hours that you're using that. So if we've used it for 50 hours, as is the case for the next question, we would simply put 50 into that rule and work out that after it's been used for 50 hours, it's now worth $837.50. And we would respond in terms of a full sentence.
Like that. Very easy. Very straightforward. Then we've got just a bit more on this one, Miss. So then we had, write your answer for 2. On average, the salon will use the hairdryer for 17 hours each week. Mm-hmm. How many weeks will it take for the value of the hairdryer to halve? So a couple of things here.
Okay, so we know that we want to look at how long will it take for the hairdryer, how many weeks will it take for the hairdryer to be
half the value,
which is 425. That's half of 850. So we're saying if it's worth 425, it started off as 850. We're saying take away 0.25 times n, and we're simply working out what n is in this case, and we're using our solve function.
So in this situation, Miss, we got n as being 1700.
Because it was hours.
Hours. So then, guys, what do we do to get it into weeks? Divide it by
17 in this case. Sorry.
Because why? It says here in the question 17 hours
each week
per week. So that's why we have to divide it by 17, and to make sure that you get that one right, divide by 17 because you've got to read the question, yeah? Mm-hmm. So when you read the question and you do that, it's easy, and it becomes 100 weeks in order to get that done. So guys, have a go now at doing exercise 8D, all of the even questions.
No, I would say do all the questions.
Okay, Miss said do all the questions. Do all the questions. Take care.